Hello everyone, welcome to this video on top 20 Linux interview question. Whether you're preparing for a job interview or brushing up your Linux knowledge, this video is for you. Linux, as you all know, is a command-driven open source operating system used widely across industries. In this session, we will cover frequently asked questions, both theoretical and practical, designed to prepare you for real-world interviews. We will be starting with basic concepts like kernel, shell, Linux architecture to advanced Linux command. So grab a notebook as we dive into mastering this Linux question. Starting up with the very first question, which is what is Linux and how is it different from UNIX? Linux and UNIX are both strong operating systems, but they are designed for different purposes and audience. Linux is a free open source and widely used on everything from personal computer to servers and even smartphones. It is constantly improved by a large community of developers, which means faster updates and bug fixes. UNIX, on the other hand, is a proprietary system mainly used in enterprise environment like large servers and workstation because it is not open source and you need a license to use it. And updates tend to be slower compared to Linux. Another key difference is flexibility. Linux supports a wide range of system and hardware, making it super versatile. Unix is more specialized and tailored for specific enterprise level tasks. In simple terms, Linux is an open source accessible to everyone, perfect for personal and professional use. Unix is more exclusive, often used in large organizations where stability and dedicated supports are key. Moving ahead with our next question, which is what is Linux kernel and why is it important? The Linux kernel is like the brain of the Linux operating system. It's the core part that connects your hardware and software, managing key resources like CPU, memory and devices to keep everything running smoothly. It handles important tasks like running multiple programs at once, like process management, organizing file and storage like file system management, and managing network communication. One thing about the kernel is the hardware abstraction. This means software doesn't need to know the details of your hardware. It just communicates with the kernel. This makes Linux both flexible and efficient. Another great feature is modularity. You can add extra features like device driver or network protocol without messing with the main system. This makes Linux super customizable, whether it's for personal use or powering servers. In short, the Linux kernel is essential for making sure that your hardware and software work together seamlessly. Moving ahead with our next question, which is what is a shell in Linux and how is it different from bash? In Linux, a shell is basically a command line interface that lets you interact with operating system. You can think of it as a bridge between you and system's kernel. It takes the command you type, interprets them and executes them. Shells come handy with features like scripting, command history and job control, which help you automate tasks and manage process more efficiently. Popular shell in Linux include bash, zsh and fish. Now bash, a short of Born Again shell, is one of the most commonly used shell. It's an improved version of original Bourne shell sh and comes with extra features like better scripting tools, command line editing and supports for array and function. Here's an easy way to understand the difference. A shell is a general term for any command line interface, while bash is a specific type of shell with advanced feature. If you're looking for something powerful and user-friendly for scripting or command line tasks, bash is a great choice. Moving ahead with our next question, which is what are the basic components of a Linux OS? The Linux operating system is built on 5 key components, each essential for smooth operation. First is the kernel, the core of Linux, meaning it manages hardware resources and bridge hardware and software. It handles tasks like memory management, process scheduling and device communication. Second is the system library. These libraries provide functions that allow application to access kernel feature without directly interacting with it. So they simplify software development by implementing core functionality, making the development more efficient. Third is the system utility. Specialized programs handle tasks like file management, system monitoring and configuration, supporting daily operation. The fourth is the bootloader. It initializes the system by loading the kernel into memory at startup, enabling boot up, meaning it's essential for enabling the system to boot up. Finally, application software. Programs like browsers or editors installed by user often via app stores in Linux, distributions like Ubuntu. So together, these components ensure Linux flexibility and efficiency. Moving on to fifth question, which is what is the init process in Linux? The init process in Linux is like the system's manager. It takes over as soon as your computer starts up. When you turn on your Linux machine, the kernel or the core of the operating system gets loaded into the memory and starts working. But the kernel doesn't handle users' process or services. That's where init comes in. Init is the very first process the kernel starts, and it always has a process ID of 1. Its main job is to set up the system and manage everything that runs after booting. This includes first, starting essential service like network setting or background tasks. Second, setting the system's mode, run level or target like whether you are using a graphical interface or just the command line. Third, keeping an eye on process and restarting them if they crash. In many modern Linux systems, init has been replaced by systemd, which is faster, more efficient and offers greater flexibility. Okay. So moving ahead with our next question, which is how do you find files in Linux? Okay, so to find files in Linux, the find command is used. Okay, this find command is used, which is designed for comprehensive file and directory searches within a hierarchical structure. So its adaptability allows user to search by name, size, modification. You can search a file by its name, size or modification or content, providing a flexible and potent solution. So this is the whole syntax. You will use find, then path, then options. Options as in you refine the searches such as type F for files or type D for directories. And then expressions. It sets condition like name, txt for matching file's name. So we'll see a quick demo. I'll open the Ubuntu Linux. Okay. I'll go on my terminal. Okay, so this is our terminal. So to find the file, firstly we'll need to create a file. We'll create the file touch, suppose file 1.txt. Okay, so we have created this file, and to find the file we'll be needing the directory we are working in. So we'll check the directory, which is home akanksha. Okay, so to see where this file has been created, we'll write find command, find, then /home, this name of this directory, akanksha, then hyphen type F, then name, then double inverted commas, and name of the file, file 1.txt. Okay, that's it. See, so it gave you the whole path where your file is. Home, then akanksha, and file 1.txt is present. Okay, that's all for this question. Moving ahead with our next question, which is what is the difference between soft link and hard link? Okay, so hard link and soft links are the two ways to create references to file in a Linux or Unix system. So let me explain you in more detail. Talking about the hard link, okay. So it's like having two identical names for the same file. Both names directly point to the actual data on your storage. For example, this is your original file and this is your hard link. So they are pointing to the same data. And if you delete one name, the original file, for example, if you delete this one, the other file or the hard link still works because the data is still there. You can think of it as file having two doorways to access the same room. Talking about the limitation, hard links only work within the same storage area, for example, file system, and you can't use them to link folders unless you're a system administrator. Now talking about this soft link, a soft link or a symbolic link is more like a shortcut you create on your desktop. It points to the file's location rather than the actual data. This makes it more flexible. You can link file across different storage area and it works for folder also. But here's the thing, if the original file is moved or deleted, for example, if you delete this original file, the soft link stop working because it does not contain the actual data and it just contains this file's address. So the actual data is connected with this original file only, with this data on the hard disk, and if you delete this, the soft link will also be destroyed eventually. Okay, so here's the table which is showing you the key differences. a pointer to the original file, reference, can link across different file, must obey the same file system, deleting the original file breaks the links, but a file remains accessible. And what's the creation command? In S symbolic link, target link name, in target link name. And for storage, it requires additional in node for the link, and it shares the same in node with the original file. Okay, so moving ahead with our next question, which is, how do you change file permission in Linux using chmod command? To change the file permission in Linux, use the chmod command. For read, you'll R, for write W, and for execute. Okay, and for 3 different group, owner, groups and other. You can modify permission using symbolic or numeric nodes. Okay, let's see how it works. So if you want to give the read permission to a file, we'll write chmod O equals to R, then the name of the file, which is file1.txt. Okay, so we have given the read permission. Now you can't write from the file, just you can read from the file. Similarly, for execution, you can give chmod u plus x, then the name of your file. For the write permission, you can give chmod g-w file name.txt. Okay, so moving ahead with our next question, which is, what are the different type of permission available for files in Linux? So in Linux, the file permission decide who can do what. Who can do what with a file. You can think of it as like a security batch where each file has 3 type of user and 3 type of action. First of all, who can access? Owner, group or others. In owner, there comes the creator of the file. In group, a specific group of users like team members who can access the file. And in others, everyone else like the visitor who are coming to see the file. And what are the actions? Actions are read, write and execute. In read, you can view the file content. In write, you can modify the file content. Whereas in execute, you can run the file as a program. And permissions are displayed as symbols like R, W and X, or the numbers 4, 2, 1. And each file shows permission for user in a format like this one. You can see here rw-r-r. Here the owner can read and write, but the others can only read. So suppose if you want to give the permission to owner only to read and write, you can use this one, and all other can just read from that file. And of course we use chmod command to manage the file accessibility, like we just discussed in the previous question. Okay, moving ahead with our next question. How do you create and manage symbolic link? Okay, so symbolic links, also known as symlinks or a soft links, are the files in Linux that point to other files or directory. We just read what are soft links and hard links, and that symbolic link, that same soft link is known as symbolic links. Okay, so to create the symbolic link, here is the command. Okay, and let's see the demo for this creation. Okay, so to create the symbolic link, we'll use ln, then symbolic link -s, then the name of our directory home Akanksha, we checked with pwd command, then the name of the file for which we want to create the link, so the Akanksha, then the name of the file file1.txt, then space, then home Akanksha, then what do we want to name this link? Suppose first one -link .txt. Okay, so this is how you created symbolic link. You can go on your files. So file1.txt. So whenever you will write anything in your first one link.txt, suppose we wrote hey, and when you will save it and you will go in your file 1.txt, discard and reload the changes, you will see that the same thing you wrote in first link.txt will be displayed in file 1.txt because you have created a link and this first one link.txt is pointing to file 1.txt. Okay. So this is all for this question. Moving ahead with our next question, which is how do you check the current path or directory? Okay. So we use this pwd command to check our current path or directory. So let's see the demo for this. Let's go on our terminal. Okay, pwd will write. So we'll see that this home Akanksha directory we are working in currently. Moving ahead with our next question, which is how do you combine two commands and what is the use of pipe in Linux? So in Linux, you can combine two commands and use a pipe to send the output of one command as an input of another. So the pipe is used to send the output of one command you are using directly to the input to another command, which allows chain command together, enabling more complex tasks in a single line. Okay, so you can say it like this is the command 1, then you are using this pipe, then this command 2. So the first command whose output will be piped and the second command that will process the output command. Okay, so let's see how it works. So suppose you want to list all the files in the directory and search for a specific file name. Okay, so we will be using ls command to list all the files. Then we will be using this pipe command and this grep to search for the specific file name. For example, first.txt. Okay, let's see. So ls command will list all the files in directory and grep command shows the output of ls command to only show that particular file. Okay, so here it showed first.txt. Okay, let me explain you in more simpler manner. For example, we will be first using only ls command. So it listed all the files present here and then we'll be using ls space pipe grep to list only that particular file, first.txt. Okay, it showed you the file. So you understood what is the use of pipe command. Moving ahead with the next question, which is how can you check for free disk space? So this you can see here, this df command, which stands for a disk free and shows available and used disk space on the system, and df-h shows disk space in human readable format. Okay, so when you will use this df command, okay, you will get output like this, but when you will use this df-h, you will get a output in a human readable format. So let's see. Suppose we wrote only df, you will get data which is not a human understandable format. So when you will write df space -h, you will get this size in kbs and mbs and used and available, which you can easily read. Okay, so this is the use of df command by which you can check for the free disk space. Okay, moving ahead with our next question, which is write a command to find files with the .txt extension containing a specific string. Okay, so the syntax for finding the commands with specific string is grep. Okay, so when you use grep, you will search for a specific file. Okay, let's see the demo for this question. Okay, so suppose we want to list all the files containing hey in them. Okay, then what we will do, we'll write grep, then rl hey, okay, then hyphen include, and then double inverted commas, asterisk .txt home, then Akanksha. Okay, so you see, when you wrote grep and you are listing all the files which contain hey, what this is showing as, you have a file name file1.txt which contains this string hey. Okay, so this is how you can find a specific string using grep command. So moving ahead with our next question, which is, what are the different ways to view the content of a file without using the cat command? Okay, so there are this 5 method by which you can view the content of a file without using cat command, which is less, more, head, tail and nl. So the command for less is less file name, more file name, then eventually for all these things. And what are the uses? When you're using less command, it will view the file content page by page. When you are using the more command, it is viewing the file content forward only. When you are using head command, it will view the first 10 lines of the file. For tail, it will view the last 10 lines. And for NL, it will view the content with line numbers. Okay, so you can practice it on your own. I'll be showing you just the less command. Okay, so when I am using less file 1.txt, see, it's viewing all the text which is present in the file. Okay, so that's all for this question. Moving ahead with our next question, which is, how do you check the current IP address of your Linux server? So to check the IP address of a Linux server, you can use the command like IP address or hostname I for straightforward input. So the simple command is IPA only. So the IPA is a part of IP suite command used to display network interfaces and their configuration, and it provides detailed information about all the network interface on your Linux system, including IP address, MAC address, interface status and many more. So let's see how it works. You will write IPA and it gave you the IP address. This is your IP address for your particular system. Okay, moving ahead with our next question, which is, what is SSH and how is it used to access a Linux server remotely? So SSH, or a secure shell, is a cryptographic protocol used to access and manage Linux server remotely. It provides encrypted communication between your local machine and the server, ensuring that data is protected during the transmission. So you can see here, this is a SSH client. It's sending information hello, okay, and this is being encrypted, meaning this hello is being converted into some another unreadable format by humans, and when this data is received to this end, it is changed to a readable format. Okay, so to access the Linux server using SSH, you can follow the steps like ensuring a SSH client is installed in your system, and you can use a terminal and you can run a particular command, and you can then authenticate by entering the service password or using a SSH key. So the basic syntax is SSH, username, hostname or IP address, and here you can replace the username with your remote server username and hostname or IP address with your particular server's hostname or IP address. So SSH is widely used for executing commands, managing file and performing administrative tasks on a remote server, which is more secure, efficient and an essential tool for server management. Okay, moving ahead with the next question, which is, what is a package manager in Linux and why is it useful? So in Linux, a package manager is like your go-to tool for managing software on your system. It automates the process of installing, updating, configuring and removing software packages or application and libraries. So it handles everything, okay. Whether you are a newbie or an experienced Linux user, it simplifies all the software management. And why is it so important? Because first, it manages the dependency. Okay. So Linux program often rely on other packages to work, and the other package manager automatically fetches and installs these dependencies for you. So when you're using a Linux system and you want to, for example, install a web browser, you will just write a simple command and the package manager, it will fetch that package from the repository and it will give back to you. Second, it keeps your system stable. So it ensures that different package works well together, preventing compatibility issues. Third, it simplifies update. With just one command, you can update all your software and keep your system up to date. Then fourth, which is centralized repository. In Linux, software comes from trusted repository, and the package manager ensures that you get verified and reliable program. Okay, so talking about some of the most widely used package managers in Linux, which is first apt, second yum, third dnf. APT also stands for Advanced Package Tool. YUM, Yellow Dog Updater. DNF, Denified Yum. So we can say in a nutshell that in Linux world, the flexibility and customization are key, and a package manager makes that life easier by automating software installation and maintenance. Moving ahead with the next question, which is, how do you terminate an ongoing process in Linux? So this kill command is used to terminate an ongoing process in Linux, which sends a signal to a process instructing it to terminate. And what's the syntax? Kill, then option, then PID. Let's see the demonstration. Okay. So by using this kill, you see that it has killed all the ongoing process in the Linux. Okay. Moving ahead with our next question, which is, how do you check systems architecture and CPU memory stats? So a command line utility or lscpu in Linux is used to get CPU information of the system. The lscpu command fetches the CPU architecture information from this particular file and it displays it onto the terminal. So this command reports data about memory, paging, disk and CPU activities, etc. And the first use of this command return the data averages since the last reboot. Further, user return the data based on sampling periods of long delays. Okay, so let's see how it works. Okay, so to view the disk statistic, we'll use the command vmstat-d. So you see, it provided all the information related to that CPU. Okay, so that's all from my side. If you have liked this video, kindly hit the like and subscribe button for Intellipaat's YouTube channel. Thank you and see you in the next video.